Alrighty, in today's video, we're going to be looking at chapter 9.1, which is our last chapter of the semester. We're going to be looking at solving systems of linear equations by substitution and elimination. All right, pretty long title. You should have seen systems in Algebra 1 and Algebra 2. We go a little bit further. We talk about three-dimensional space as well. So this should be a nice review of some of the things that you should seen in your time. The very first three questions, we're going to just practice substitution. The next three questions, we'll practice elimination. We'll do a couple of three-dimensional questions, and then we'll do a couple of word problems. So here we go. So you're going to be given a set of two equations or a system of two equations. So 2x minus y equals negative 12, and 3x plus y equals negative 13. Your goal is to solve this by substitution. So you want to find something that has the easiest coefficient to deal with. And in this situation, this one is the easiest one. It has a 1, so therefore there will be no division. So what you do is then you take this equation here and you solve for y. You determine which letter has the easiest one. So I'm going to subtract 3x. So therefore I get negative 3x minus 13. I cannot combine those. So now what I do with this is I substitute this y into this first equation. So now I get 2x minus parentheses, and we'll replace y with this equation, which is negative 3x minus 13 equals negative 12. You've now produced an equation in which it's linear, so that's a lot easier to solve. So the first thing we're going to do is take this imaginary negative 1, and we're going to distribute this out. So it becomes 2x plus 3x plus 13 equals negative 12. Combine our like terms, so 2x plus 3x gives us 5x plus 13 equals negative 12. And then I'll subtract 13 on both sides. So I get 5x equals negative 25. Then divide by 5, and I get x equals negative 5. Once you have that value, you can now substitute this x and solve for your y. So this gives you negative 3 parentheses when we plug in to indicate multiplication. And negative 3 times negative 5 is 15. 15 minus 3 is 2. Now that I got my x and my y, this becomes negative 5, comma 2. And that would be your answer. All right, so let's do another one. You'll have ones that look like this. Oh, man. That was number one. And this was on page 570. This will actually be number 8. And it'll be 3x plus 6y equals negative 12. And 2x plus 4y equals negative 8. So again, you want to look for the easiest one to solve for. And in my opinion, I think the smaller the coefficient, the easier it is to deal with. So I'm going to solve for this x. So I take the second equation, and I'll solve by getting rid of my y. That gives me negative 4y minus 8, and then I'll divide by 2. So x gives me negative 2y minus 4. I will take this equation and I'll plug it in for this x in the first equation. So that gives me 3 parentheses, negative 2y minus 4 plus 6y equals negative 12. Now I can easily solve for my y. Distribute first. So 3 times negative 2y is negative 6y. 3 times negative 4 is negative 12 plus 6y equals negative 12. And then I get negative 6y plus 6y would cancel each other out, and I get negative 12 equals negative 12. When this happens, they want you to write it out as an equation. So what you do, since you solved for x, you'll write it as like this. So you'll do your little squiggly bars or squiggly curses, brackets, whatever you want to call them, and you'll write in what the x equation is, which is negative 2y minus 4, comma, your y. So in this case, since I solved for x, I'm going to plug in a value for y, and then I'll know my x. So whatever y value I choose, it'll give me my x that goes with it. And then you'll finish this off by saying such that y is any real number. I'm not going to plug in imaginary numbers. So yes, in past, you would say this is infinitely many solutions, which is true, but more specific, it's infinitely any number y I want, but then it have a specific x value that would go with that y value I choose. So it's not just any x and y combination, it's a any y, and then it'll give me my x. All right, let's look at another one. Not number 9. No, it is. It's number 9. Let's look at one like this. 2x plus 5y equals 33. And then we have 3x equals negative 3. Obviously, in this one, I believe the 3x is the easier one, so I don't got to do any subtraction. So I'm going to take the 3x equals negative 3, divide by 3, and x equals negative 1. I'll take that value, and now I'll plug it in. So this becomes 2 times negative 1 plus 5y equals 33. It gives me negative 2 plus 5y equals 33. I'll add my 2. And that gives me 35. Divide by 5. And that would give me 7. So my ultimate answer is negative 1, comma 7. All right, let's talk about elimination now. So let's look at question 16. 16, we have 2x minus 3y equals 8. And 8x plus 5y equals negative 2. When you're dealing with elimination, your goal is to try to add your equations up to eliminate them. Easiest way to do is pick some numbers in which you can multiply your equation by, so that when you multiply it, you can then add them and they will delete or cancel or eliminate. Now, when I look at this, I can say, well, 2 can easily become an 8 if I just multiply it by a 4. But the issue is if I just multiply it by a 4, it'll give me another 8, and 8 plus 8 is 16. So I want it to be able to add to eliminate. So I'm going to make it a negative 4, so it produces a negative 8. But once I make that decision to multiply the 2x by negative 4, I have to do it to every part of that equation. So this will now give me negative 8x plus 12y equals negative 32. And then I have 8x plus 5y equals negative 2. These will cancel, which is what I wanted. 12y plus 5y gives me 17y. And negative 32 plus negative 30, negative 32 plus negative 2 gives me negative 34. I'll divide by 17. And I get negative 2. Once I've determined this one, I can choose either of the original equations or the new equation, and I just plug it in. I'm just going to play around with the equation I haven't messed with yet. So it's giving me 8x plus 5 times negative 2 equals negative 2. And then I get 8x minus 10, but again, doesn't really matter, equals negative 2. I'll add 10. This will give me 8, divide by 8. So x gives me 1. So my answer here is 1, negative 2. It doesn't matter which one you choose. At the end of the day, we will all get x equals 1. All right, let's try 17. 17 is negative 2x plus 3y equals 13. And we have 4x plus 2y equals negative 18. And so again, I'm looking at this and I'm like, man, if I just make this a negative 4, I could cancel these out. So that's what I see. So if I just multiply it by 2, it would do that. But again, if I decide to multiply this by 2, I have to multiply the entire equation by 2. And again, you can go by any process that you want, as long as at the end of the day, your two equations that you have, when you add them up, it will delete one of your numbers at least. So this will give me negative 4x plus 6y equals 26. And then 4x plus 2y equals negative 18. Add these up. That'll eliminate. This will give me 8y. And this will give me 8 divided by 8. So y equals 1. Oh, then again, it doesn't matter which equation you choose. I just like the one that hasn't been messed with too much. So therefore, I get 4x plus 2 times 1 equals negative 18. 2 times 1 is 2. I'll subtract 2 now. That gives me negative 20. Divide by 4. So x gives me negative 5. So I get negative 5 comma 1. That's my answer. Let's do one more to make sure you have plenty of examples. Let's look at number 20. Number 20 is 5x minus 10y equals 9, and negative 5x minus 4y equals 9. In this situation, notice I wrote the problem down wrong. It's just negative x plus 2y equals negative 3. Man, that was bad. So 5x minus 10y equals 9. Negative x plus 2y. Oh, I just jumped down. My eyes went to 23. I see now. All right, so okay, so looking at this, I can go, man, if I just had this one as a negative 5, I would be able to eliminate. But again, if I do it to this one, I have to do it to the entire equation. So I get 5x minus 10y equals 9, and then negative 5x plus 10y equals negative 15. This will eliminate. This will eliminate. And so I get 0 equals 9 minus 15, which is negative 6. This is an untrue statement. So when you get an untrue statement, this would be a no solution. All right. So let's play around with some three-dimensional stuff. Let's look at number 33. So 33, we have x plus y equals 4. And then we have y plus 3z equals negative 1. And then we have 2x minus 2y plus 5z equals negative 5. There's a lot of process to go with this. I'm going to start off with a substitution type of process. And then on the next one, I'll kind of go about a elimination type of process. In this case, I have an x and a y here and a y and a z here. So I'm actually going to solve for y so that whatever equation I get, actually, yeah. I'm taking. If I solve for y, that'll give me an equation with an x, but then I'll have an x and a z. Yes, and then I can solve for z and then plug it in and have an equation. Yep, perfect. That's the route we'll go. So on this first step, I'm going to solve for y. So I'll subtract x. So it gives me y equals negative x plus 4. That's my first one. Then I'm going to take this guy, and now I'm going to substitute. Let's do a different color so you can see. I'm going to substitute this y in for that y. So that's going to give me negative x plus 4 to begin, plus 3z equals negative 1. This time I'm going to solve for z, trying to get the equations in which they all have one letter involved in it. So I'm going to add x and subtract 4. So I'll add x and subtract 4. So it gives me 3z equals negative 5 plus x. You can rearrange that if you would like. Divide that by 3. I think I'll divide them all independently by 3. So I get negative 5/3 plus 1/3 x, or you can keep it as x over 3. But now I have not an x, that's a z. So now I have two equations that I can now substitute for y and z, and then I'll have an entire equation with x. Once I solve for x, then I'll be able to substitute both back into the y and z, and then now I have all of my answers. So here we go. So this will be 2x minus 2 times my y equation, which was negative x plus 4, plus 5 times my z equation, which was negative 5/3 plus 1/3 x equals my negative 5. And then I'm just going to do a bunch of distributing. So negative 2 times negative x is positive 2x. Negative 2 times positive 4 is negative 8. Positive 5 times negative 5/3 is negative 25/3. 5 times 1/3 is going to be 5/3 x equals negative 5. I don't want to deal with fractions, so I'm going to do something kind of crazy here. I'm actually going to multiply everything by a 3. So that give me 6x plus 6x minus 24 minus 24 minus 25 plus 5x equals negative 15. So I did that because not that I don't like fractions. It's a lot easier to do it without it. So now I get 6x plus 6x plus 5x. That's going to be 12, 17x minus 49 equals negative 15. So then I add 49 to this. That would be a 430, so 17. So I get x equals 2. Now that I have that value, I can now back substitute it into all of my x's. So this gives me negative 2 plus 4, which is just going to be 2. And then this would be negative 5/3 plus 1/3 times 2, which actually gives me negative 5/3 plus 2/3, which is actually negative 3/3, which is negative 1. So that's what my z is, that's what my y is. So I now can put it all together and I get 2, 2, negative 1. So that is a substitution method. Next one I want to show you is an elimination method. So let's look at number 35. We have our three sets of equations, 3x minus y plus z equals 2, negative 6x plus 2y minus 2z equals negative 4, and negative 3x plus y minus z equals negative 2. All right, so my goal here is I want to get each set of equations, 1 and 2, and then you could do 2 and 3, and the goal is to eliminate z. You can actually eliminate whatever you want, actually. But just for sake of a good lecture here, I'm going to take the first two equations. And my goal is to eliminate z. So I'm going to multiply the first equation by 2. So that's going to become, so I'll take this first equation times 2. So that's going to give me 6x minus 2y plus 2z equals 2. And then my second equation is negative 6x plus 2y minus 2z equals negative 4. When I do that, it looks like everything eliminates and I get 0 equals negative 2. So without even being able to do anything, I can't do anything with this situation here. Oh, actually, I was going to say this is a no solution, but it's not because this is 4, that would be 0. So this is a true statement. So that's great, but it doesn't allow me to do anything. So what I'm going to do now is I'm going to look at the third equation. It's going to give me the exact same situation. All right, so won't be able to do elimination here. Just choose to solve for a letter. Doesn't matter to me. All right, so we'll look at this. Let's solve for, we'll look at z. So when I do that, I'm going to move everything over. So I get 2 minus 3x plus y. All I did was change all the signs and move them over. Now I'm going to plug it into this. Plug it into this value. And I think what I'll do is I'll then solve for y. So here we go. So with that information, that'll give us negative 6x plus 2y minus 2 times 2 minus 3x plus y equals negative 4. Distribute, distribute, distribute. So I get negative 6x plus 2y minus 4 plus 6x minus 2y equals negative 4. Combine like terms, the x's, man, everything just goes away. And then I'll end up with negative, and I think it's going to happen no matter which way I go. So in this situation, I just need to solve for 1. So I decided to solve for z, so I don't even have to worry about doing all of this. Actually, I'll tell you what. Keep that there just so you know. Just so that you know that this is the case. So in this case, it's going to be whatever my x is, whatever my y is, and then depending on what x and y is, my z will be 2 minus 3x plus y, such that x and y are both real numbers. So there's a system of 3 equation for you there. All right, next thing I want to do is do a couple of word problems. We've seen these before in different problems, but now we're going to approach it with a mindset of systems. Number 53, it says a tour organizer is planning on taking a group of 40 people to a musical. Balcony tickets cost $29.95 and regular tickets cost $19.95. The organizer collects a total of 1,048 from her group to buy tickets. How many people choose to sit in the balcony? So we have two types of people. We have balcony people and we have regular ticket people. So this is going to represent my balcony. This is going to represent regular. And regardless of how many did each, I know if I add them up, I'll have 40. Now I have a price tag on each one of them. So balcony tickets were $29.95 times X plus my regular tickets, which is $19.95 times my Y. And I know I collected a total of 1,048. Now I have a system of equations and you can solve it by any methods. I find elimination to be the easiest, not elimination, sorry, substitution to be the easiest. Solve for whatever you want. Let's go with solving for y. So that means that y would equal 40 minus x. All I did was just change the sign, move it over. So now I'm going to plug it in. So I get 29.95x plus 19.95 times 40 minus x equals 1048. Distribute away. 29.95x plus, couldn't tell you. Let's see. I feel like it's going to be close to 800. $798 to be exact. So 798 minus 1995x equals 1048. Combine like terms, that looks like that would give me $10 even. So 10x plus 798 equals 1048. Subtract 798 from that. That gives me 250. Divide that by 10. Oh, I lost my x. So that's going to give me 25. So that tells me what was the question. It said, how many people choose to sit in the balcony? Since X represented balcony, it was 25 people. Biggest thing on that homework, make sure you go back and see what did the question actually ask. All right, let's do one more. This one here, again, we saw in a different earlier chapter talking about solutions, but it says how many ounces each of a 12% alcohol solution and a 30% alcohol solution must be combined to obtain 60 ounces of an 18% solution. So you have some type of 12% solution plus some type of 30% solution. But if I combine them, total, I'll have 60 ounces. I don't know how much of each I have, but that's what it'll produce. I do know that if I have 0.12 of my X solution here plus my 0.30 of my Y solution, it'll produce me 0.18 of my 60 ounces of solution. So now I have a system of equations. And again, best thing to do is I just solve for Y, but again, doesn't really matter. Solve for whatever you want. So I get Y equals 60 minus X. I'm now going to substitute that in. This is actually what we did last time. We just went straight to that process. But here's the thought process behind that process from last time. 0.18 times 60. Ooh, gives me 10.8. I'll now distribute. So I get 0.12x plus 0.3 times 60, which is 18, minus 0.3x equals 10.8. Combine like terms. Let's see, 0.12 minus 0.3 gives me negative 0.18x plus 18 equals 10.8. So minus the 18. So I get 10.8 minus 18, and I get negative 7.2. Divide that by our negative 0.18. And I get 40. But the question said, how many ounces each of a 12% and a 30% must the solution contain? Since I let X be 12, I need 40 ounces of 12% solution. And then I would need 60 minus that. So I would need 20 ounces of a 30% solution to produce a 60 ounce 18% solution. All right, again, we did this in a different section, so hopefully that's a pretty good review. If you have any questions, feel free to email me. Other than that, I'll see you in the next video. Bye for now.